Hey there, science students. Here we go again. This is Mr. Zana. We're going to be doing a slides ed puzzle. Today we're covering Newton's second law, force. So Newton's second law of force is very important. We're going to tie in some of the things that we've already learned in the past, like acceleration. And we need to go through our champs really quickly for this ed puzzle. You need to have your voices off while you're doing your ed puzzle. Raise your hand if you're having a technical difficulty or don't understand one of the questions, and either myself or Ms. Konopik, whichever class you're in, will come over and give you a hand with that. Watch it and have some fun. Please stay seated during the ed puzzle and watch and be prepared for an end of class exit ticket. Then you will be successful in completing this ed puzzle. So we are still in Unit 3, as you can see here, and the blue arrow is pointing to Newton's laws, okay? So we're on the second of 3 of Newton's laws. And after you're done with this, you should be able to answer what Newton's second law is, and you should be able to answer or fill out some of these essential vocabularies such as mass, net force, friction, some of those words, okay? Right here, you're going to see Newton's second law on the second page of our unit organizer. Again, you should be able to fill in a definition of the second law. You should already have your first law filled out because Ms. Konopik went over that with you before this class. So what we have is our cue. What? Well, today we're going to look at Newton's second law, force, and how it is calculated. How are we doing this? We're going to do an ed puzzle, and then it says a Google form, which is just another one of our warm-ups, which you should have done before this ed puzzle. And then why this is going to help us understand how mass and acceleration affect force. So to get us started, we're going to do a short video here.
Mass is a measure of an object's ability to resist being accelerated by a force. That means the more massive an object is, the harder it is to make it move if it's at rest, or to stop it if it's moving. The nifty thing about mass is that it doesn't necessarily have to do with size. Think of a big pile of rocks and a big pile of feathers. Both piles are the same size, or volume, but it would take a lot more effort, or force, to move the pile of rocks than it would to move the pile of feathers. The reason? Rocks have more mass than feathers, because they're more dense. To show how it's harder to accelerate something with more mass, picture a student and a teacher, each sitting at rest in a rolling chair, facing each other. Let's also say the teacher is more massive than the student. When they both push off each other, they go rolling backwards. Notice how the student goes back much farther and faster than the teacher. The teacher accelerates less, since she is the more massive of the two objects, and it takes more force to accelerate her than it does the student. All this has to do with Newton's second law of motion, F equals ma. It says for a set acceleration, an object with more mass requires more force to get it moving at that set acceleration. As mass increases, the force required to accelerate or decelerate that mass increases as well. Now, don't you feel massively smarter?
All right. So there is your quick introduction to Newton's second law via some cute little rhinos. All right, so Newton's second law of motion. Newton's second law states that the total net force acting on an object is equal to the object's mass times its acceleration. So F equals ma. An example would be is if you had a 2 kilogram ball and you wanted to move it 4 feet per second squared. You would need to multiply the mass, 2 kilogram ball, times how fast you want it to go, 4 feet per second squared, and you would come up with 8 newtons of force needed to move it. So force is measured in newtons, which is fitting. It's Newton's second law. So the abbreviation for newtons is just a capital N, all right? So we're gonna go through some questions here. Remember to make sure that you read them completely. Don't just rely on me reading them to you, but here in the ed puzzle, you can also go back and listen to the information again before you read it and answer it. So make sure you know what the answer is prior to picking an answer. So our first one, how much force is needed to accelerate a 66 kilogram person at 2 meters per second squared? Remember, force is equal to m times a, mass times acceleration. So it'd be mass in this case would be 66 kilograms. 2 meters per second is the speed or acceleration we want. All right. Next question. What is the force needed for a 1,000 kilogram elevator that is falling at 9.8 meters per second? All right. Next one. A 50 kilogram skater is pushed by a friend and accelerates 5 meters per second squared. How much force did the friend use? All right, next one. A car with a mass of 300 kilograms is observed to accelerate at a rate of 4 meters per second squared. How much force was used to produce this acceleration? All right, here we go. A cart with a mass of 50 kilograms is pushed to an acceleration of 5 meters per second squared. What force was required to reach that acceleration? All right, those are your questions. Here's our review for the day. Today we looked at Newton's second law of force and how it can be calculated using mass, acceleration. How? Well, we did an Edpuzzle to practice calculating these forces, and inside that Edpuzzle we also saw a video that expressed how to do the calculations. So why? Well, this is going to help us understand how an object's mass contributes to how much force is needed to accelerate it. All right, and here is your exit ticket. What do the letters in the following formula represent? So what does the F stand for? What does the M stand for? What does the A stand for? Okay, so I hope you had a good time with this Edpuzzle, and we'll see you next time. Thanks for paying attention and doing such a great job answering the questions.